Welcome to this first tutorial about exploratory data analysis. We're going to learn a little bit more about a dataset called mtcars. mtcars is a dataset that's available in base R, and you can read a little bit more about it by running the line in code in line 2, which is help. When you run it, you can read more about it. It tells you how many observations, where the observations are the number of rows, and how many variables, where the variables are the number of columns that data set has. Well, usually we don't always have all the data sets inside R, so there are other ways to learn a little bit more about the data sets, which we're going to learn in this very tutorial. So to load it, you can just run line 5, which says data, which attaches it so we can be able to work with the variables or the columns within it. First, we're going to look at the structure of that data set. So we're going to run line 8, and the structure tells us more about the types of data that is contained in that data set. So we can see we have again 32 observations and 11 variables, and then all the 11 variables have been mentioned here. The first one is MPG, which is numeric. The next one is CIL, which is numeric, disk, which is numeric, and all that. Remember, from help you can read more to know what they really mean. If you want to view the data set, you can run line 11, which says view with capital V, and then it will open a data matrix window where you can see all the data. Thankfully, this is a small data set, so you can be able to see all of it, but sometimes the data sets are big, so you cannot see all of them at the same time. However, to get a feel of the data set, there are other methods of looking at it. For example, rather than running view, you can use head, which gives you the first 6 rows of the data and gives you all the variables for the first 6 rows. Let me run it again so you can see that. But you might want to look at a little bit more rows, so you can also edit this command and add the number of rows you want to look. Like in line 15, we've said that you want to see 10 rows. So when I run, I can be able to read 10 rows of the data, and for each row I see all the variables. If I want to look at the last rows of the variable, I change from head to tail, and the same rules apply. If I want to edit and see more of the last rows in that data set, I can edit and put the number of rows I want to see. Now, as you're exploring the data, you want to look at the summary of the data. When I run the summary, it gives me information about all the variables. Now, it gives me some measures of central tendency, which you look at in the next topic. But for now, I wanted us to look at one particular thing, and that is for all this data, we do not have missing value. So we are lucky this data is clean. Sometimes the data has missing value, and when you run summary, you can be able to see the missing, how many are missing or in S. Exploration involves a lot of visual exploration of the data set, and of course you can explore a single variable depending on the type. The histogram can be used to look at the distribution of numeric data. So here we're going to look at the histogram of the variable called MPG. In R, for you to reference a variable, you say the name of the data set, and then to reference the variable you use a $sign and then the name of the variable. So and these other arguments here, this is the main title, and this is the label for X, and this will be the label for Y. So when we run this line, we get the histogram, which shows that this data is now we know, even just from the labeling, that MPG references the miles per gallon. We can see that it's the data is not really normally distributed. It's a bit skewed. We can also look at the box plot of it. The box plot, which is a 5-number summary. When you look at the box plot, you can see the skewness, like the top tail is longer, the top whisker is longer than the lower whisker. You can add a little bit more to probe the data further. For example, this box plot has not considered other categorical variables that are within that might exist within the data set. So here we're going to do the box plot of the miles per gallon, and also looking at the cylinder. So when we run this line, now you see that depending on the number of cylinders, for the cars that had 4 cylinders, they ran a lot more miles per gallon, but also very variable. So some of them went very far, some very near. But generally, those with a lot more cylinders tend to go for low. The cars that have higher numbers of cylinders tend to cover a lot less miles per gallon. Here, when you consider a cars that have 8 cylinders, you can see there is that dot at the bottom, which is an outlier, meaning there was that particular car make which had which covered very few miles per gallon, because yet even when you consider it together with the cars that had the same number of cylinders, it was far much lower miles per gallon. Now, when we break it this way, we see there is an outlier. Yet when we looked at it without breaking it, there was no outliers. So whenever we are exploring the data, the more we probe, the more we see patterns that might be, and we can be able to say that some patterns might are there relative to other measurements that we have. Another way to also look at it is by plotting. So in line 35, we do a plot, and this plot will just be a scatter plot. And when you look at the scatter plot, for miles per gallon being the y variable and horsepower on the x variable, you can see there tends to be like a curve, or the way the dots are, there is like some curve. It's not a line, it's not, but the curve tends to decrease. The more horsepower, the less miles per gallon being covered. So there is this pairs function in R, which can be used to also look at a number of variables at the same time. So here you can see the 4 variables that were selected, and you get to see all the scatter plots. So in this first scatter plot, it's where we have along the x is the miles per gallon, along the y is the horsepower. This one where the cursor is right now is along the x is the horsepower, while along the y is the weight, and so on and so forth. And this is a symmetric thing. So what you see on this lower side is basically a replication of what is at the upper part. So these are nice ways of being able to explore. If we consider horsepower and weight, we can see there might be some line forming here. So here there might be a linear relationship. When you consider weight and displacement, it's not really linear, but there tends to be some curve or something like that. When you consider miles per gallon and displacement, also there tends to be some curve, but not linear. So from that, we can be able to quickly think of what other kind of analysis we can do with our data set. Thank you.